Hello, everybody. This is Gigi from Kauai Community College. We are talking here about the power rule. That's how to take the derivative of x to the nth power. Okay. So here, suppose you have x to the fourth, for example. Okay. Let's just use a definition of derivative first and kind of observe and see what's going on here. By definition, it would be the limit as f of x plus h, like this, f of x plus h minus f of x all divided by h, right? So that would be x plus h to the fourth power minus x to the fourth power over h. And so if you expand out x plus h to the fourth power, we will know that that would be x plus h times x plus h times x plus h multiplied by another x plus h, right? So this first two would be x squared plus 2xh plus h squared. And then the other set would be the same. X squared plus 2xh plus h squared. And if you multiply these two polynomials out, you would get a very long thing. And that would be this part right here, right? So, trust me, use your scratch paper and check my work. That's what it is, right? So what you notice here is x to the fourth power will minus with x to the fourth power, that gives you 0, right? And then if you notice, everything here has an h in it. Everything has an h in it. And as a matter of fact, the first term that you see there has h to the first power. So when you take everything and divide it by h, that first h will be gone. But every other terms after that will have an h, like this, right? So when h is approaching 0, then this go to 0, this go to 0, that go to 0. So we will just have 4x to the third. So we say that the derivative of x to the fourth power with respect to x is 4 multiplied by x to the third. Okay, so that is using the definition of derivative. Now, I want to be able to generalize this, right? So what are we going to do? We're going to go ahead and look at for any non-negative integer n and take the derivative of x to the nth power. Okay? Now, if it was x to the fourth, like how we had just did in the previous slide, we would say that would be, take the n, which would be 4, and then x to the third power. And we have just proven, that using the definition, right? But let's do this for any given number, non-negative integer n. Okay, so by definition, we will have the derivative is limit as h go to 0 of x plus h to the nth minus x to the nth, all divided by h. Now, do we really have to go multiply x plus h times x plus h times x plus h times x plus h all the way to the n power? Well, I don't even know what n is. So, but if we were to observe what we call the binomial multiplication, you might have to trust me on that or look it up. And you can see that when we multiply it out, the first term would be x to the nth power. The last term would be h to the nth power. And then we would have the next term here is the number n. Like earlier, you had 4x to the third, right, times h. So that would be n times x to the n minus 1 multiplied by h. That term right here has h in it, and then the exponent on the h will increase until it gets to the h to the n, and then the exponent on the x would decrease until there is no more. And then there's always going to be some constant here. Now for what we are doing, it really doesn't, we're not interested in what that constant is. The only constant that we need to know is that one right there, which is n, right? Now, x to the n power minus x to the n power is going to be gone. And what you will notice is that everything has an h in it. Everything has an h in it, as in red there. And then so when we divide everything by h, this right here, the h will be gone, and that will just give you n times n x to the n minus 1. And then the rest of these, even if we were to divide by h, then there will be one less h in there, but they all have a factor of h in there. So what happened is when you are taking the limit as h go to 0, all of these things right here is going to go to 0. So that just leaves you with n to the x minus n. And that is how the power rule works. What you'll do is you take the exponent, put it down, and then change the exponent out for one less. For example, the derivative of x to the n 10 power is, you take the 10, move it down, that would be 10, and then 10 minus 1 is 9. So the derivative of x to the 10th power is 10x to the 9th power. Okay? Now, what if you have, if someone asks you, what is the derivative of x to the e power? Would that work? Well, e is non-negative, right? Is it an integer? No. Right? We know the number e is an irrational number. But, as it turns out, we could also apply that rule to here. And if we did, it would be e x to the e minus 1 power. Bring the exponent down and then one less. Okay, now an extension of the power rule would be what happens if it's not an integer, right? So I'm going to try to maybe talk about something that's very useful, like the derivative of the square root of x. This is something that you should know because you will see it all the time. So, by definition, we would say the derivative here is limit as h go to 0 of square root of x plus h minus square root of x all divided by h, right? So we know that we are supposed to rationalize for a problem like these from how we know to take the limit. So we would multiply by 1, and 1 would be square root of x plus h plus square root of x over square root of x plus h plus square root of x. Now when you have a thing multiplied to its conjugate, like a minus b times a plus b, we will have a squared minus b squared, the difference of two squares, with a being square root of x plus h and b being square root of x. So you will have then square root of x plus h square, and square will undo square root, so you will just have x plus h in there, minus square root of x squared, all divided by, on the denominator, you have h times square root of x plus h plus square root of x. Okay, so we can see now that square root under square root under square, or square under square root, you will have just x plus h minus x, and x plus h minus x is going to be 0, so you have h on the numerator. Over h on the denominator, square root of x plus h plus square root of x. And you can see h divided by h is 1. And then when h is approaching 0, this right here goes to 0. So you will have the derivative of square root of x with respect to x is 1 over square root of x plus another square root of x. You have 2 square root of x. And that is something that you should know. This is one of the basic derivative that you should know. Okay, so I started out saying, hey, the power rule actually works for non-integer numbers as well. Okay, so what does that mean? The square root of x can be written as x to the 1/2 power. So if you were to go and take the derivative of x to the 1/2 power, will equal to, remember, the derivative of x to the n power, the power rule say, would be n times x to the n minus 1. So, take the 1/2, put it down here, x 1/2 minus 1, and 1/2 minus 1 is negative 1/2. But you might be saying, but my answer was 1 over 2 square root of x. How do we get there? Well, negative exponent is the reciprocal of positive exponent. So what you really have is the derivative of square root of x is 1 over 2 times x to the positive 1/2, and 1/2 exponent is square root of x. So you get exactly the same thing, right? Same answer. So the power rule actually works for rational exponents as well. And what I mean by that is not just x squared, but it could also be, say, a square root of x, but it could also be like cube root of x, like this. The derivative of cube root of x is the same as, and we say cube root of x can be written as x to the 1/3, right? So then what we can do is take the 1/3 down, x 1/3 minus 1, and 1/3 minus 1 is negative 2/3, and then negative exponent, you get to bring that down. So that's 1 over x to the positive 2/3. You can write it that way, or you can write this back to radical. The bottom number is the root, so keep root of x squared. Okay, but what do I want you to know? I want you to know the derivative of square root of x. And the derivative of square root of x is 1 over 2 square root of x. Just because you will have to use it over and over and over again. Okay? Now, another one that kind of follow the power rule is the 1 over x. Okay, so here, based on the definition, you will have limit as h go to 0 of 1 over x plus h minus 1 over x all over h multiplied by, we are going to multiply by 1 to clean that up. And the 1 here for a complex fraction is the least common denominator over the least common denominator. That first fraction is going to zap out, and you will just have x minus 1, and the x will zap out. You have 1 times x plus h is x plus h, but since there's a minus in the front, you have to distribute that negative, so that would be minus x minus h. Or we can think negative 1 times x plus h is negative x minus h, all over h, x times x plus h. Then x minus x is 0. Then h divided by h is 1. So in the numerator, you would have negative 1. On the denominator, you have x times x plus h. Well, what happened when h is approaching 0? This goes to 0. You have on the denominator, x squared is the product of x times x. So the numerator would be negative 1, and the denominator would be x squared, and that is a derivative of 1 over x. And this is another derivative that you should know, just like the derivative of square root of x is 1 over 2 square root of x. We should know the derivative of 1 over x is negative 1 over x squared. Okay, so since this is in the power rule section, or it's an extension of the power rule, the question would be, could we use the power rule? How? Well, 1 over x can be written as x to the negative 1 power. So if we were to apply the power rule, we would bring the negative exponent down. So I will have negative 1 x minus 1 minus 1, right? Because the derivative of x to the n power, the power rule said, is n times x to the n minus 1. So that is what that is. So that will be negative 1 multiplied by x to the negative 2 power. But what does it mean to have negative exponent? That is to keep negative 1 there the same, because it doesn't have a negative exponent. The x to the negative 2 power get to go down here, and it becomes x to the second power. And that is exactly the same as if you were using the definition. So it's up to you if you want to use the definition or if you want to use the power rule. However, what you really need to know is the derivative of 1 over x is negative 1 over x squared, which is something you should ingrained in your brain and be able to apply it quickly.